Good afternoon, everyone, and welcome to Dr. D.R. Patel Vidyapit, a center for online learning. I'm your faculty for this course, that is OMB AI ML 303 and OMBBA 305, that is Performing Analytics with Python. Guys, in the last session, I have started with Unit 3, that is Python libraries. And from this Unit 3, I have covered some of the points of this Unit 3 and some points or some topics of this Unit 3, that is Python libraries, are left. So first, what I will do here, we will cover, or I will cover the remaining part of this Unit 3, then we'll proceed to the Unit 4. So please confirm in the chat box that I'm audible and my PPT is visible to all of you in the chat box. Please confirm. Am I audible and is my screen is visible to all of you guys?
Yes, sir, it's visible.
Okay, thank you. So give me a minute. Here I'm just giving the link for the feedback. So later on, when I conclude the session, you can fill this Google form, that is feedback form. So before I could proceed to the rest of this topic in this Unit 3, what are the contents of this Unit 3? The content of this Unit 3, that is NumPy, basically getting familiar with pandas, that we have covered in the last session. And in this session, we are going to learn about the common statistical data analytics tools or data analytics techniques in Python. Means what? How common statistical functions or how common statistical data analysis can be done using Python. So here first I will explain the theoretical part and then I will explain it with a practical concept. Means what? First I will explain the concept theoretically, then I will explain the same concept practically by using the Google Colab. Is it fine for everyone? Guys, is it fine? Please
Yes,
give
sir.
your response in the chat box. Yeah, thank you. So in the last session, I will just go through the content that I have already covered. So in the last session, I have covered about the introduction to the NumPy. What is NumPy? NumPy is basically a numerical Python, which provides the library for performing numerical computations, which provides the data structures, which provide the functions for working with arrays and matrices. So basically for working with arrays and matrices, it provides the functions, it provides the data structure, and which is NumPy is widely used for various tasks, including for numerical operations, scientific computing, and data analysis. So you will find the use of NumPy in every application of Python. Means what? In every Python program, you will find the use of NumPy. And these are some of the features of NumPy that we have already discussed. That is multi-dimensional array. Means what? The NumPy will allow you to create a multi-dimensional array. Now, there are types of arrays, that is single type, single dimensional, two-dimensional, and multi-dimensional. Single dimensional array means what? Basically, what is an array? An array is a collection of data items, isn't it? If I have to store the marks of 100 students, then how I can store the 100 marks of students in Python? So for that, I need to create 100 variables in order to store the marks of 100 students. But the difficulty here is that I need to remember the variable names of 100 students. If I have to process, if I have to make some processing, if I have to find, if I have to calculate the percentage. So I need to remember the all 100 variable names. So instead of defining 100 variable names, what I will do here, I will create an array having 100 elements, having 100 storage places. And that array name is having only a single name. So by using a single name of that array, I can address, I can reference the marks of 100 students. Not only I can refer, I can perform the computations, I can process the marks. So here I just need to remember only a single name, that is the array name. So that is the main advantage of defining the arrays, isn't it? So now we have different types of arrays, that is single dimensional, two dimensional, and multi-dimensional. I'm not going into the details of these types of arrays, but just I will like to give you a brief information about single dimensional, two dimensional, and multi-dimensional. So when I say single dimensional array means what? It is having only a single row and single column. So one column and one row or multiple rows means that I'm having a one dimensional array. So one dimension means what? An array which contains only a single column, isn't it? What is two-dimensional? Two-dimensional array is nothing but a table, is nothing but a matrices, which consists of more than one column and more than one row. So a table, a matrices is called as a two-dimensional array, multiple rows and multiple columns. So this is two-dimensional. Now, what is multi-dimensional? Multi-dimensional means what? The sets of two-dimensional arrays combined into a single array, that is called as multi-dimensional arrays. For example, I can combine three two-dimensional arrays into a single dimensional array, that is called as multi-dimensional arrays. A multi-dimensional arrays is nothing but a set of two-dimensional arrays. So there are different applications of these different arrays. Now you are saying that why I need to use multidimensional, why I need to use two-dimensional. There are different applications. There are different needs, isn't it? That's why they have introduced these types of arrays: single dimensional, two-dimensional, and multi-dimensional. So I'm not going into the details of multi-dimensional, single dimensional, and two-dimensional. Here we are considering from the point of view of NumPy. So NumPy basically allows you to create multi-dimensional arrays. So it has the object called as ND array, and by using that ND array, we can create multi-dimensional arrays. So NumPy is an ND array, which is a powerful data structure. Basically, array is all about a type of data structure, like a list, like a tuple, like a dictionary. In the same way, arrays are also a type of data structure that we use to store list of values, arrays of values. So it provides the mathematical functions as well. NumPy provides a wide range of mathematical functions. Like in the last session, we have seen we can perform the statistical functions. We can find the mean, mode, median. We can find the minimum value. We can find the maximum value. For all these things, NumPy provides the built-in functions. So these are the features of NumPy. So basically, what is NumPy? NumPy is a data structure. A NumPy will provide you to create a multi-dimensional array, and NumPy will give you, provides the range of mathematical functions for performing computations, for performing the for performing different data analysis. So we have seen how to create a NumPy practically in the last session. Again, I'm not going into that. So how we can refer the values of an array? We can refer the values of an array by specifying the array name And in the square bracket, we need to specify the index number. So every array, the element of every array is referred by its index value. And remember that the index of arrays starts with 0. So in that way, the index of the first value. So for example, I have created an array of 100 students, marks. So the marks of first student that you will find in at the 0th index position. The marks of the second student that you will find at the 1 index number 1 position of the array. So what is the maximum index that I can refer here? That is always size minus 1. Means what? Since the array index starts with 0, what is the maximum array index that I can refer here? Suppose that I have created an array called as, say, marks of 100. So what is the maximum index value that I can refer? That is size minus 1. So that is 100 minus 1. That is 99th. So when I say student in the bracket 99, in the square bracket 99, so what it refers? It refers the marks of 100th student. Why? Because the array index starts with 0. So that's why the highest index value that I can refer in array is always its size minus 1. Then we have also seen with the pandas. What is pandas? Pandas is a powerful data manipulation, and pandas are built on NumPy. Like I said that if you import the pandas library, you don't need to import the NumPy. So pandas is also a powerful data manipulation and analysis library for Python, which provides data structure functions for handling data structure. So pandas are more powerful than your NumPys. Pandas will provide you more computation libraries, more functions than your NumPy, because NumPys will provide you the basic computation functions, but pandas will provide you the scientific functions so that you can perform data analysis. So pandas is widely used in data science, in data analysis, and data pre-processing tasks as well. What are the features of pandas? The features of pandas that we can create a data frame. A data frame is a primary data structure in pandas that represents a tabular data with labeled rows and columns. So it is just like your arrays. So data frame that we can create with pandas. Pandas basically is a data structure which provides functions for handling tabular data and time series data. So for handling the data which is presented in the form of a data frame, in the form of a tabular data, or which is data is provided in time series, we can perform data analysis on this time series or tabular data with the help of the functions provided by the pandas. So pandas are more powerful than the NumPys. So we can create data frames, we can manipulate the data, we can reshape the data. Like we have seen, reshaping means what? Transforming your data into another form. So for example, if I'm having categorical data, that is male and female. Suppose that I'm having categorical data that is male and female. But see that for data analysis, the data should be presented in numbers. So here I need to convert this male and female into a numbers. How I can perform? I can perform with the help of the functions provided in the pandas that we have seen. We can convert male into 1 and female into 2, or male into 0 or female into 1, that I have shown you with the help of a practical example. So here we can perform data cleaning, we can perform data manipulation, we can find out the duplicate values, You can find out the anomalies. You can find out the blank values with the help of the functions provided by the pandas. So as you can say that pandas are more powerful, and pandas are basically used for data analysis, and they are basically used in data science. And pandas are built over NumPy. So that's why all the libraries, functions provided by the NumPy are automatically available to the pandas as well. So I have shown you all these things. That is how we can perform data manipulation. For example, how to perform, how to find, how to handle the missing data, how to read and write a data into the data frame as well. So all these things I have shown you in the last session. Now we'll come down to the topic of this session, that is the common statistical data analysis techniques in Python. Means what? How we can perform the statistical analysis or statistical data analysis, or how we can use these statistical methods or statistical functions in Python. What are the functions? What are the parameters? How I can perform the statistical data analysis? Means what? How I can find mean, mode, median. So all those things means what? The statistical functions, how I can use those statistical functions in Python. But for that, we need to have the knowledge of statistical functions, isn't it? So that only we can use it in Python. So here I'm going to explain the how I can use that function in Python, what are the parameters of that function. But to use that function, we need to know what that function will do. What is the use of that function? What is the purpose of that function? Then only we can use it in Python. So basically, first we look at the descriptive statistics. So there are different types of statistics. So first we are looking at the descriptive statistics. We also have predictive statistics. So here a descriptive statistics which will summarize and describes the main characteristics of the data set. Means what? Basically here we are looking at the historical data. What happened? So that we are investigating here in descriptive statistics. We are summarizing and we are finding out the main characteristics of my data set. For example, I'm finding out the mean. Mean means what? The average. What is the average values of my data points? What is the median of my data points? What is the mode of my data points? So that I can do in descriptive statistics, which provides the information about the average or a typical value, that is average, mean, median, the middle value, and the mode means the value which is often repeated in the data set. So measure of variability, that is range. We can find out the range. What is the range? Range means range specifies a value between the maximum and the minimum. That is called as the range, isn't it? So range will represent a value which is between maximum and minimum. So if I subtract the maximum value minus minimum value, I will get the range. Variance means what? What is the difference? How my data is spread? How my data is how my data values or data points differ or far from the mean value in my data set, that I can find with variance and standard deviation. How my data values deviates from the standard mean, that I can find out with the in the descriptive statistics. So the measure of variability describes the spread or the dispersion of the data. So by using this variance, using this range, using this standard deviation, we can find out, we can describe how spread my data points is and about the dispersion of the data. So that I can do in a descriptive statistics. Other statistic techniques which includes the percentiles, quartiles, and interquartiles range as well. So what I will do here, now we'll go to the practical part of this descriptive statistics. So guys, do you understood about this descriptive statistics? Now I'm going to show you practically by using the Google Colab how we can perform these functions, that is mean, median, mode, range, variance, and standard deviation. So if you have any questions, please. Is the array part of the Python built-in data structure? Yes. Kelvin, yes, it is a part of Python built-in data structures. That is what I've said now. The NumPy will provide you the ND array object, and with that we can create the multi-dimensional arrays. And on the basis of that, the pandas are built. So ultimately, by using pandas, we can create the data frame. Isn't it? So, of course, yes, arrays are part of the Python built-in data structure as well. So guys, shall I proceed? Yes.
Sir, can you tell once again descriptive statistics?
Descriptive statistics. Okay. See that in descriptive statistics, actually we are working on the historical data. What happened? Why this kind of thing has happened? So here I'm finding out the reasons. Here I'm finding out the summary of the data. How I can find out? I can find out through the measure of central tendency. What is the average values of my data set? What is the middle value of my data set? Which value is often repeated in my data set? That I can find in a descriptive statistics with the help of the functions which are provided in Python library. So here I can find out the range, the variance, the standard deviation. The standard deviation means what? This kind of range or this kind of variability that will provides how your data points are spread, how dispersion of your data is. The spread of data means what? How your values in your entire data set, how the values in your data set are spread, how they are deviated, how the values are far from the standard mean or standard deviation. That will be represented by these range, variance, and standard deviation. We can find the dispersion of the data. We can describe how spread my data is. If the standard deviation is higher, then it means that your data is more spread. If it is less, then we can say that the data is not that much spreaded or that much dispersed. So the measure of variability that we can find with the help of range, with the help of variance, and with the help of standard deviation. Variance and standard deviation are same, but standard deviation will give you more precise information about the spread or about the dispersion of the data. In the same way, range will also give you the spread or the dispersion of the data. Means what? Spread represents the difference between the maximum value and the minimum value. So if I am having 1 to 100 values, 1 to 100. So what is the range value here? That is 100 minus 1. So how spread my data is? That is 99. So the 99 will be represented by the range, but the variance and the standard deviation will give you more scientific way of how your data is spread. The range will not give you that much correct information about the spread of your data, isn't it? Here I have found out the minimum value 1 and maximum value, that is 100. And what is the range? The range is 99. So it is not giving you the complete information about the spread of the data. If you want to find out a precise information about how your data is spread, the dispersion of the data, then definitely you need to go for variance or standard deviation. That will provide you that how your data points, how these numbers 1 to 100, they are far from the mean Mean is what? Mean is your average value of the data set. So from how far your values in the data set differ from the standard mean, that you can find out with the help of variance and standard deviation. So the variance and standard deviation will give you more precise information about your data set, how spread the values in your data set, what is the dispersion of the data set, that will be provided precisely by variance and standard deviation. So am I clear with this?
Yes, sir.
Yeah. So now we'll go to the practical aspect of how we can perform this descriptive statistics by using Python, or in particular by using the functions in Python. So first let me go to the Colab library. Colab. So I will share the screen here. So just tell me, is my Google Colab is visible to all of you guys? Is it visible?
Yes, sir.
Yeah. So now here we are performing the descriptive analysis. We are finding out the mean, mode, median, and variance and standard deviation. So for the first thing first, we need to import the libraries. So here I have imported the NumPy as NP and Pandas as PD. So now the second thing is that we need to create a data set. How to create a data set? By using the functions that is called as data frame from, you can see, from Pandas library. So here we have imported two libraries, that is NumPy and Pandas. NumPy as NP. Now I can refer NumPy in my program as NP, and I can represent the Pandas library with the name PD. So here to create the data frame, we have to call the function that is a data frame from the Pandas library. So here data is equal to PD, that is the name of my Panda library, PD dot data frame. And you can see here to this data frame, what I have provided. Yes, guys, what is this data structure? Can anyone respond this? What is this data structure is called as? Can you see the highlighted area? So what this data structure represents here?
It's a dictionary, sir.
Yeah, correct. It's a dictionary, because we can see that this is a key. Key is age, and its values are from 25 to 33. Again, one more pair of key and value that you can see here, that is income is my key, and its values are the actual income. So here I'm providing, there are different ways of creating a data frame, isn't it? We can provide an array, you can provide a dictionary, you can provide a tuple. So there are different ways of creating a data frame. So here I'm providing a dictionary to a data frame function. So now what this will do, this will create a data frame with age and income from the dictionary. So here I have created a sample data set, isn't it? If you want to work with, if you want to perform any data analysis, the first thing first is that you need to import the libraries, that is Pandas and NumPy. Then the second thing is that if you have a data set in your system, you need to read it, or if you don't have a data set, for the purpose of demonstration or for the purpose of testing it, you can create a data set like this as well. So here I have created a data set with the name, I have created a data frame that is data. So here data represents my data set, which consists of age and incomes of various age and incomes. The next thing is to display the statistics using the pandas. Means what? I want to describe the data. So to describe the data means what? What is the mean? What is the mode? So for all these things, what we can do here, we can call the function called as data.describe. So data is what? Data is my data frame. As you can see here, I have created a data frame, isn't it? So now from this data frame, I'm calling the function describe. So this describe function, see that when I put the mouse button or mouse cursor on this describe, you'll find its description. Even I don't need to explain what this describe function will do, which will generate the descriptive statistics. Descriptive statistics include those that summarize the central tendency, dispersion, and shape of the data sets, distribution, excluding the non-values, means null values, and analyzes both numeric and object series, as well as the data frame column sets of mixed data types. And the output will vary depending on what is provided, referred to the nodes. So whenever if you want to know the use of this function, what is the use of this function, what are the parameters that it will accept, you just need to write the function, and after that just put your mouse pointer on that particular function. This will give you the entire description of that function. Like this here, the describe function will provide you the descriptive statistics like the central tendency, like the dispersion of the data and the shape of a data sets. So that's why when I call the data dot describe, this will give me the information about the measure of central tendency, the shape of the data, and what is the dispersion of my data, how spread my data is. So I have stored the result of the data.describe into summary underscore stats variable. And after that, if I print with the help of a print function, what I will get here, I will get this kind of details that you can see here that I have highlighted here. So actually, I have actually run this this code earlier. So here I will get the output of that describe function. As you can see here, age and income, the count of values, the mean, the standard deviation, the minimum, the 25%, 50%, 75%, and all this, it will give you a description about your data set, like the central tendency, that is mean, mode, median, the variance, and standard deviation. So that is how we can find out. We can find out the characteristics of my data. What are the characteristics of my data set? How we can find out? We can find out through with the help of this describe function, isn't it? It is as simple as that. So just call the describe function on the data set and print the values of that data set with the help of a print function. You will find the characteristics of your data set in terms of its central measure of central tendency and its standard deviation and shape of your data set. See that before performing data analysis on your data set, you need to know the characteristics of your data set. What are the characteristics of your data set? Characteristic in the set, the variance, the standard deviation, the measure of central tendency. So all these things will give you an idea about your data set so that you can go to the next step. So this will also give you, the describe function will give you the mean, mode, median as well. That is mean. But if I want to find out the median, then, or if I want to calculate the mean separately, so what I will do here, I will just call the function mean here. So mean underscore age is equal to, now you can see here, I'm using NP here. Now you you can find out that why I have imported NumPy. So I want to perform the computations on the dictionary, isn't it? So that's why here I have imported NumPy. So now I am performing some calculations like mean, mode, median on the data set. So here I am finding out the np.mean means what? Why mean is been defined in NumPy. So np.mean, I am providing the data set, and from that data set, I am providing the age. I want to find out the minimum or the average age of my data set. This is the data set. So this is the complete data set. And from this complete data set, I am providing the age key. If I want to find out its values of age, I need to give the key. So what is the key? The key is age. So from this age pair of values or age values, I want to find out the average age. So here I can find out from the data set, I am giving the key that is age, so that I can find out the minimum, the average age, that is the mean age of my data set, that is of column age. So this will find out the average age. And if I have to find out the average income, the same way here I just need to provide the another key, that is income. So here I am giving the income. So now when I execute this statement, these two statements, what I will get here? I will get the average age and average income. So that you can see in the output as the mean age is at 29.6 and the mean income is 61,500. Even you can simply copy this code and execute in the Colab web browser. You can also will get the same result. So here, these two lines will give you the average age and average income with the help of the mean function of the NumPy, which is represented by NP. Now the median, if you want to find out the median, that is the middle value, the same thing. What is the middle age of the age and what is the middle income of the income, that I can provide np.median data set I need to provide, and from that data set I am providing age. So I want to find out the middle value of the age from my data set, and again I want to find out the mid income of my total data set, that is of income. So when I execute these two lines, what I will get here? I will get the middle age is 29 and the mid income range is 60,000. So this is how I can find out the median values, that is the mid values of my data set. Next thing, if I want to find out the mode means what? The values which are repeated in the data set. So what are the values which are repeated more often? That I can find out by using the mode function, in the same way that we have used the median as well. So here I'm using the np.median, providing the data set and key as age. So this will give me, sorry, here. So mode underscore age is equal to data of age dot mode of starting with 0. And again, for income, I'm giving the mode underscore income is equal to data of income dot mode of the mode of from the first element, that is of the index value 0. Sorry, index number 0. So this will give me the y0 here. Y0 I'm specifying here. I want to find out its location, isn't it? So what this function will do, the mode function will find out the values which are repeated. So that's why here I'm giving it as 0. Means what? it should start from the first, this one, and it should end with the last value. So that's why here I'm giving the index value as 0. So here I need to consider all the values, isn't it? I need to consider all these values. So that's why here I need to provide the index of my array, that is data set. So these two statements will give me the mode, and if I execute the mode, then I will find the mode, that is the value which is repeated more often, that is 28, and the income which is repeated more often, that is 60,000. That you can confirm here is that 28 is repeated twice, isn't it? And again 60,000 is repeated twice, no other values are repeated. So my mode age is 28 and my mode income is 60,000. So this is about mean, mode, and median. Now the next thing is range. Like I said, that range, how we can find out the range? Simple thing that if you deduct the maximum value, sorry, minimum value or maximum value, if you deduct the minimum value from the maximum, you will get the range. Suppose that these are the range of values. So when a minimum value is reduced from the maximum, you will get the range. But for that, here Python provides the functions. So with the help of the np.ptp, we can find out the range of age and the range of income as well. So the function name is ptp to find out the range. So this will give me the range of age, and this will give me the range of income. So as simple as that. Only thing is that we need to remember the functions. Which function is used for which purpose, isn't it? So that's why here we need to have a statistical knowledge when you're performing data analysis. Because when you're performing the data analysis using Python, you need to have a background. You need to have a prior knowledge of statistics. What mean means, what mode means, what median means, what is, how I can calculate the, what is the range, what is variance. After that, you can implement those concepts of statistics in Python by using its associated functions like mean, mode, median, and np.ptp as well. So ptp is a function which is used to find the range. So here, actually, you can also find out the range by manually also. But for that, you need to find out the maximum value and you need to find out the minimum value. So again, suppose that, yeah, this is only for small numbers. But if you are having a huge data set, then in that case, are you going to do it manually? Not possible. Is it possible, but it is time consuming. And again, there may be errors in finding out the minimum value and maximum value. Yeah, you can find out through Excel. You can sort the values from minimum to maximum, that is in ascending manner, and you can find out that, but that is time consuming. So when Python is providing you the functions, so with the help of that functions, we can perform, we can find out the range, like by using the function called as ptp, np.ptp. The ptp function is been defined in the pandas. As you can see here, np stands for pandas, as we have imported pandas as, this one is been defined in the numpys, that is np. So ptp is been defined in numpy. np represents the numpy library. So numpy.ptp dataset of age will give you the range of age, and np.ptp dataset of income will give you the range of income, that you can see here. Range, yeah, as you can see here, range of age is 18. So the difference between the maximum value and the minimum value is 18, and range of income, that is the difference between the highest income and the lowest income is 35. So what is the use of this range? See that the range will give you this idea about the spread of your data points, data set in your data points in your data set. But the range will not give you a precise information about the spread of your data points, about your data set. So for that, we need to go for variance. Variance or standard deviation will give you more precise information about the spread of your data. If you get a, a standard deviation of highest value, then it says that your data is spread more. So for that, we need to use the variance. How we can use it variance? Again, by using the function called as VAR. In the same way that we have used np.ptp, ptp for range and VAR for finding out the variance. So here, if I say here variance underscore age is equal to np.var data set and specifying the age. So this will give me the correct and precise information about the spread of my data set. Spread means what? How the values, how these values are away or far from the standard mean. What is the mean? Mean is the average value of my data set. So what these values 25, 30, 22, 35, 28, or whatever the range, whatever the standard mean of this. So what, how this 30, number 30 is away, spread from the standard mean. So that information is provided by the variance and standard deviation, or for the sake that is range as well. But range will not give you the correct information, but variance will give you the correct information about the spread of your data points in your data set. So for that, we just need to call np.var, provide the data set and provide the column name. So that will give you the variance for that particular column in your data set. And in the same way, np.var data set of income will give you the variance, the information about the spread of data of the column income. So this will give me the result, that is variance of age is 28.24 and variance of income is this one. So as you can see here, the range. So range is giving me an entirely different value and variance is actually giving me an entirely a different value. So you can yourself find out the information which is given by the range and variance. So that's why variance will give you more information. Again, if you want more precise information, then you will go for standard deviation, that is SD, which will give you the more correct information, more precise information. You can see that the precision here you got only after decimal, you will got only a single zero. Now you can see here how many digits are given after the decimal point. So this will give you more precise information, that is standard deviation, that how your data points are spread, how your data points are away from the standard mean or the standard deviation. So that you can find out with the help of the std function of the NumPy. So std, var and ntp or ptp, they are defined in NumPy. So here I'm calling the std function to find out the standard deviation of my data set of column age, and in the same way I can find out the standard deviation of my data set of income just by calling the std function. So when I call this function, when these two statements are executed, what I will get? I will get the output like this. So this is about the descriptive statistics. So if you have any questions about descriptive statistics, please go ahead and ask your query. Please share the code, sir. Okay. How do you that to make business decisions? How far the data is away from the mean? See that here, Nath, we are actually finding out how spread my data points are in my data set. I'm not taking any decisions here. I'm not making any big business decisions here. I'm just checking out what is the spread of my data, how spread my data is. If your data, if the standard deviation is more, then you can say that your data is more spreaded. So here I'm not taking I'm not making any business decisions. I'm just knowing the characteristics of my data set, that is finding out what is the mean, what is the mode, what is the median value, what is the range, what is the variance, and what is the standard deviation. So any other question, guys? Do you understood the concept of this descriptive analysis, how we can perform the descriptive analytics by using the Python, or how to perform descriptive analytics techniques in Python? Am I clear with the concept? Am I audible?
Excuse me, sir.
Yes.
Yeah, on the mean,
Uh-huh.
mean, median, and
What's your name?
mode,
First, tell me what's your name.
Juvencio Piri.
Yeah, go ahead.
On the mean, median, and mode, when you were inputting the data for the, yeah, maybe just come, yes, come down a bit to show up to mode. So when you were putting the data for mean, to find out the mean age and the mean income, medium age and the median income, you input equals to np.mean. But when it came to mode, your input on mode is mode underscore age is equal to data, and then square brackets age. So I noticed that difference. Why the difference?
You noticed it correctly. See that learner. This mode function is defined in the data frame. As you can see that here, the median function, and the mean function is defined in the NumPy library. You correctly pointed out the difference here. The mean and median, they are defined in the NumPy library. Okay, but now, as we have correctly pointed out, that the mode function is defined in the data frame. So if you want to find out the mode, then you have to use this mode function along with the object of data frame. So am I clear? Is your doubt clear?
Yes, sir. Thank you.
Yeah. So guys, any other query? Please, can you share the Colab slides with us? Colab library, Colab code. Okay, I will see that how I can share it, Nath.
Hello, sir.
Yes.
I have one question.
Yeah,
Sorry.
yeah, go ahead.
Yeah, in mode, you written mode and that 0. Why we have using that? Yeah.
See that, like I said that here, what is mode? Tell me, what is mode?
Mode
Nath,
is the
what is mode?
middle value, no?
Mode is not middle value. Median is a middle value, guys.
Yeah.
Mean is the average value. Correct?
The mode is the most frequent value.
Yeah, mode is the value which is repeated. So what is the frequency of the values of 25? What is the frequency of 25? 25 frequency is 1. What is the
One.
frequency
Yeah.
of 30? That is again 1. What is the frequency of 22? Again, it is 1. Because 22 is not repeated. It is only one time. But we can see that 28 is repeated twice. So the mode of the age is 28. Since the value 28 is repeated, if you compare the frequency of other values. Now, why here I have given as 0? See that here, whenever you see, like I said, that if you want to refer the elements of a data frame or an array, you need to specify its index value. What is the index value of this 25? That is 0. Index value of 30, that is 1. Index value of 22, that is 2, 3, 4, 5, 6, 7, 8, and 9. What are the total values here? That is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, why index number is highest index number is 9? Because index number starts with 0 always. Remember this. So the index number of the first value is 0. So that's why the highest index number that I can refer for this age is 10 minus 1. What are the values here? Size is what? 10. So 10 minus 1, 9. So when I say age of 9, age in the square bracket say 9, what value I will get here? I will get the value as 33. As you can see here, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it means that if you want to refer any value of your data frame or an array, you need to specify the array name and its index value. So in order to provide rather all the values one by one to this mode function, I have to start with the index value 0. So this index value 0 will start from this 25. After that, it will become 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here I'm providing all the values of this age to this mode function, so that the mode will calculate the number of occurrences of these data values. So I have to start with 0. If I say here as 1, then this value is not considered. 25 is not considered. Why? Because you have given 1 means what? You want to start from the index number 1 and to the last value. So why 0? Because I want to start from the first, isn't it? Because when you want to find out the mode, you have to consider all the values in the array, isn't it? So that's why here I have given the mode dot in the square bracket as 0. So is your doubt is clear? Is it clear, guys?
Yes, sir.
Yeah.
It's clear.
Sweetie repeated. What content I repeat here? Someone with the name Sweetie has said repeated. What do you want to repeat, Sweetie? Sweetie, if you could.
I think she was referring to the mode.
Sir, mode values. Okay. So is your doubt is clear, Sweetie? Is it clear? Yeah. So she was talking about mode values. Okay. Thank you. So this is about the descriptive statistics. So before this session could be ended, I have given the link for this session. Sorry, the feedback for this session in the chat box. One more time here, I am giving it in the chat box. And I request all of you to please give your remarks in the feedback. And again, I request that whatever query that you have, whatever question that you have, whatever suggestion that you want to give, please give it in the doubt clearing session only, or doubt clearing session if it is possible. See that here I want to answer your queries. I want to solve your questions. Okay. So when there is face-to-face or when there is one-to-one question and answer sessions, then your queries will get resolved immediately. Giving a remark in the feedback will definitely going to solve your query, but you need to ask the questions in these sessions as well. So I request you to.
So I have a question.
Hello.
Okay, so like you said, if you have a data set that is far from the mean, what could be the possible cause, or what does it suggest to you?
What you're saying? If you have data,
if you have a data set that is far from the mean, what does it suggest, or what could be the possible causes?
If my data set
an outliers or what?
See that here, I think you are Perry. Who is talking?
I'm asking that if you have a data set that is far from the standard deviation.
Can you put your question in the chat box so that I can understand clearly? Can you type it in the chat box? See that again, I have got your query little bit, so I will answer it. See that by performing the central tendency, we can find out what is the average age of my, in this case, what is the average age? What is the average salary? It is giving me the information, nothing more than that. What I can do, I cannot do anything here. If my mean is so and so, what I can do here? I cannot do anything here. If my mode is so and so, what I can do? I cannot do anything here. I'm not taking any decisions on the basis of this. Guys, please remember, I am finding out the central tendencies, values only. If your data set is far from the mean, what could be the possible causes? Like I said, that I'm giving the answer that if your data set is far from the mean, then you can say that your data is very much spread. Isn't it? Your data is very much spread. Your data is dispersed. So in order to analyze your data set should be should have more spreaded. So that is a good thing, that you are having a data set which the data set which is far from the mean. So it is good that I can analyze now I can analyze the data. If the spread is less, if your data spread is less, so in that case, if you analyze the data, the results may not be accurate. The inferences that you will get may not be accurate. So it is always advisable and suggested that your data set should be more spread. Your data set should have more spread. That is what is advised, so that you can analyze the data. And when you, after that, see that what you're saying, that your data set is far from the mean. So it's a good thing. Now you can use the mathematical functions. When you use the mathematical functions for analyzing the data, that will give you more correct information about the about your analysis. So in that way, we have to take it. In that way, we have to take it. If my mean is far, if my data points are far from the mean, it's a good thing that we can say that my data is more spread. And it is always suggested that the data should be more spreaded. So we cannot find the causes here. I'm having the data set. What I can do here? What are the causes? What could be the possible causes? Possible causes, we cannot do. It's a data set. There, see that here we are having. See, here I'm having the age 25, 30, 22, 30, 28, 40, 32, 28. This is my data set. So if my mean is far, if my data points are far from the standard deviation, if my data points are far from standard deviation, how will I find out? I have find out from the variance, isn't it? So if my values are far from the standard mean, so it means that I'm having, my data is more spreaded. I'm having more spread data. So whenever you want to perform the data analysis, it is advised that your data should be more spreaded. So that we can find out by using the variance and by using the standard deviation. You can find out how spread your data points, how spread your data set is. Isn't it? Mean will give you the average value. So average value, when you see that here, what is my mean? My mean age is 29.6. My mean is 29.6. So now, if my standard deviation, as you can see here, this is my standard deviation. So this is my variance. So what it means that, it means that your data is spreaded. Your data is very much spreaded. And if you have large amount of data and that is spreaded, then you can analyze better. You can apply your mathematical functions, and whatever predictions, whatever result that you will get, that they are more accurate, they are more correct. So I think I have solved your query. Outliers, not to everyone. If you have, if your data set is far from the mean, what could be the possible causes? Nath is also saying that outliers. Outliers means what? The data point which does not fit into your data set. That is called as outliers. So, any other questions, guys? Any other query?
Sir, where we can get this course, sir?
Which one? The Colab?
Yeah, Colab course. Actually, I have checked with Unit 3 in Swayam portal. These are not available.
No. Swayam in Swayam it is not been given. Who is talking? Nath, are you talking? Nagaraj, see that on Swayam you will find out only the PPT. You will find out the course material, but this is entirely different. This is practical aspect. So what I will do here, I will try to share this Colab, this one notebook with you. But the thing is that if it is only a single one, then I would have simply copied and pasted into the chat box. But it has many codes here. Okay, I will try to share with the mentors, and I will tell the mentors to share this with you all, guys. Is it fine?
Yeah, sir. Easy to practice for us.
Yeah, definitely. I will share it. So
you can
again,
also take the screenshot and for right now practice, because I've done like that.
Yeah, you can also do that. If you can take a screenshot, it's fine. It's very much fine. It's okay.
Yeah.
But the thing is that the screenshot will not give you the entire code, I think. I don't know
Yeah,
about.
in segment I've taken, because I could copy the entire code, the range variance until
Okay, what I will
last.
do here, I will try to copy this entire, the first one, and I will just paste it into
that
the.
would be better.
Okay, I will do it.
You can paste it in the chat.
No, your message is too long. Please try sending multiple shorter messages. So it is not allowing me to paste the entire code into the chat box. It is saying that.
Actually, I've taken the screenshot, so you can just, I'm in the group, so you can get in touch with me. I'll share you on the WhatsApp. Whoever is asking the question.
Yeah, Nagaraj is asking. Okay, what I will do, I will try to share it through mentors.
Yeah.
Is it fine?
Okay,
Yeah.
sir. Okay, thank you.
So any other questions, guys, regarding this descriptive analytics? Yes. Any other questions? Shall I conclude here, guys?
Yes, sir. You may conclude.
So before I conclude here, I request you to fill the Google form and give your feedback. And with this, I would like to conclude the session here. Thank you everyone for joining and for watching this. See you the next time. Until then, it's a very goodbye for now. Have a great day ahead. Thank you very much for joining this session.